Hello, today we are going to talk about chemical equilibrium. In a chemical equilibrium, the topic will be a state of dynamic balance, factor affecting chemical equilibrium, and using equilibrium constant. In order to start explaining the first topic, let's go over a chemical reaction. On this chemical reaction, we had the nitrogen reacting together with the hydrogen, producing ammonia, and the free energy of the forward reaction is a negative 33.1 kilojoule. And this reaction eventually can reach the equilibrium, and the rate of the forward reaction will equal the rate of the reverse reaction. So this is one of the features of the equilibrium where the rate of the forward reaction equal the rate of the reverse reaction. That will be one of the main characteristics of the chemical equilibrium. In the reaction also, there is another feature that will be the concentration of the reactant in equilibrium will be constant. At the same time, the concentration of ammonia in equilibrium will be constant. So there is no change in the concentration during the equilibrium. The fact that concentration or also can be pressure are constant, it doesn't mean that they will be equal in equilibrium. And the other feature is when you reach the equilibrium, because the two reactions is happening at the same time, we call dynamic equilibrium because at the same time the reactant are producing ammonia, they are going back and decomposing in nitrogen and hydrogen. So those are the main feature of the equilibrium that you need to know for the equilibrium. There is another concept related to the equilibrium that we have to keep in mind. Notice that all the substances here are in gas state, so the equilibrium will be homogeneous equilibrium. So those equilibrium where all the substances are in the same aggregation state, we call homogeneous equilibrium. That's another concept that will be important to know about equilibrium. We can also express the ratio of the concentration in equilibrium that will be equal to the concentration of the product, which is in this case ammonia, to the power of 2, and over the concentration of the reactant, that will be hydrogen, to the power of 3, because the coefficient here is 3. And the concentration of nitrogen will be to the power of 1 because the coefficient is only 1, and that will be the ratio of the concentration. When this chemical reaction reach the equilibrium, the ratio will be equal to the equilibrium constant that we will call KEQ. That will be the equilibrium constant. It's only when the concentrations are constant, the forward and reverse reaction are equal, and also it's a dynamic. During equilibrium, in the equilibrium state, the free energy will be equal 0. So those are the most important concepts related to the chemical equilibrium. In our next video, we will be talking about factors that will achieve the equilibrium to the left, to the right, based on the modification or alteration to the chemical equilibrium. Thank you for watching. This is it for today.